All right. So we left off in class talking about our transformation of log graphs. And so we were on example number 8B. And we discussed that this was a shift 1 unit up. Reason being is that we were given our K value. It's the value that is being added on the outside. Sorry. Um, from there, you should have drawn your graph. So because there is no H value given, your vertical asymptote is still at x equals 0. Your function, however, instead of it being at 0, 1, your y-intercept, it was shifted up. Your x-intercept, it was shifted up 1 unit. So this is at 1, 1, and you have a new intercept, okay? And then here, the domain. So your domain is from 0 to infinity. Range still negative infinity. Your asymptote still at x equals 0, but your intercept. So let's kind of talk about the intercept. So when we're talking about this intercept here, we are basically saying at what value does this function equal 0, right? So we're looking for when does this function equal 0? Well, in order to think about this, you want to think about it as an exponential. In order to do that, we need to rewrite this a little bit, right? So in order to find out what x is, I'm going to subtract 1, right? So now I have log x equals -1. Okay, so we have log x equals -1. And so you're asking yourself 10 to the -1 power equals what? Well, 10 to the -1 power is 1/10. So 1/10 is the same thing as 0.1. So therefore, your intercept, your x-intercept is now at 1/10, 0. Okay. So that's why that works that way if you're trying to find it. So remember, anytime you cannot actually see or find your x or y intercept, doesn't mean it doesn't exist. It means that you have to do a little bit of math to get there. So when we're looking for if we're looking for our x-intercept, we're going to let y equal 0. And if we're looking for our y-intercept, remember, that's us letting our x equal 0 and evaluating, okay? Which is what you did on example 8A. So on example 8A, here we need to define what is the value here. What is this, right? In order to find what that is, we had to let x equal 0. So when we let x equal 0, we ended up with natural log of 2. All right, concavity. So it is concave down. Therefore, our rate of change is decreasing. Our limits. So our left-hand behavior, the furthest left that our function can go is to the right of 0. So the limit as x goes to the right of 0 is -infinity. Our right-hand behavior is as x's go to the right as x increases. What is y doing? And our y is also increasing. All right. Notice that I make sure I use the proper name. So this isn't an f, it's not called f of x, it's called h of x. So make sure you are paying attention to that. Next, we had f of x. So for your f of x, you had natural log of 3 minus x. Okay, we talked about this. Before you evaluate the transformation, you want to make sure you factor out your b. Your x needs to be positive and 1. So this needs to be a positive 1. So what do I need to do to make this positive 1? We factor out a negative. So we divided each one of these by -1. So factor out -1, right? -1, and we're left with x minus 3. So reflect across the y-axis. That's because our c equals -1. And shift 3 units to the right. That's because our h equals 3. Weird 3. Okay. Because our h shifted, that means that our domain shifted. Notice that. And our vertical asymptote shifted, which is going to change our domain. Because of the shift and the reflection, our domain was completely transformed. Our domain is now from -infinity up until 3, and that's because I shift the function and then it was reflected. Okay, your range is from -infinity to +infinity. We have a vertical asymptote at x equals 3. We have our intercept is at 2, 0. Because remember, it was at, it would have been at 1, 0. And then I would have gone 3 units to the right, and then I would have reflected. And so that's why, with me reflecting where I'm at now. So, We are here at 2, 0, and if you don't see that it's 2, 0, then you can always plug in and do the math. Always an option. Okay, and then for your y-intercept, we plugged in 0, and we end up with a natural log of 3. The concavity here is concave down, and our rate of change is decreasing. Our limits, so the limit as f of x, as x goes to negative infinity, so as x goes forever to the left, f of x is increasing, so f of x is going to infinity. And the limit as it approaches 3 on the left, because on the right it doesn't exist, it's going down towards negative infinity. Okay, so those are our transformations. Now we're going to go to the next part. 9, applying what we've learned to a situation. All right, as you can see, was on a mission to get everything in one slide and not have to go to multiple slides. So it's all jam-packed on here. And you should have plenty of room on your paper. All right, so it says an exponential function of the form g of x equals b to the x minus h plus k is shown in the table, okay? Use the table to answer the following questions. So the first thing you want to do is try to figure out what is happening here. The decimals may not help me figure out what's happening, but I can recognize a pattern here and go from there. So I see that this is a +1, +4, I mean +2. I can count, guys. Sign that I need to get home. And +2, +2, +4, +8, +16. So what do I notice is happening here? Well, from here, I notice that there is a common, can't even talk, a common ratio. So this is times 2, times 2, times 2, times 2. What this lets me know is that my function that I'm focused on is 2 to the n of something, right? So what's being transformed here is going to be 2 to the n, something 2 to the some power, okay? It told me here that I have some shifts taking place, and my job is now to figure out what are those shifts. Okay, we're going to start off simple here by describing the end behavior. So with the end behavior, we're asking ourselves, what is happening as the function goes to the left? What is happening as the function goes to the right? So we're going to write out the limit as x goes to negative infinity. What is g of x doing? G of x is, looks like it's getting smaller and smaller to closer to 1, I'm going to assume, because they show me another 1 value. Then it says the limit as x goes to positive infinity. What is g of x doing? Well, g of x is getting bigger and bigger without a bound. So we're going to say going towards positive infinity. Okay, what is your k value? So your k value is the shift, your horizontal shift up and down, okay? Because this is exponential, that means your k value comes from your asymptote, your limit that it's approaching, right? And so for this problem, notice here, as the limit as x goes to negative infinity, g of x is approaching 1. It's approaching 1 because there's a horizontal asymptote. Okay. And when we know the horizontal asymptote, that means we know our k value. So we know that our k equals 1. And that's because there's a horizontal, y equals 1 is a horizontal. I'm on my old board and it just feels like it is a horizontal asymptote. Okay, so we know our k. Now it says output values change proportionally as input values increase in equal length intervals. Use this fact to determine the base of the function. So we've kind of already determined our base of our function. How do we determine our base? Is that we found our difference, and then we found that instead of a common difference, it has a common ratio. That alone lets us know that it's it's exponential. And we know that our base has to be 2. So we know the base equals 2. Okay, so we're going to use the point 4, 3 to find b and k, the value of h. So we're going to plug in what we do and solve for what we don't know. And we can use 4, 3. We could have used 3, 2. But we're going to use 4, 3 just because I think it works out a little bit nicer and better with it. Okay, so I'm going to plug this in. I'm going to let this be my input and this be my output. We know that our b is 2 and our k is 1. So we're going to plug in what we know. We have g of x is 3 equals 2 to the x. Sorry, I know my x. My x is 4. 2 to the 4. 2 to the 4 minus h plus 1 for k. Okay. Okay, sorry. So now we gotta solve for h. So we're gonna go back to our skills that you learn in algebra classes, algebra 1, algebra 2, to get h by itself. So up first, we have to subtract 1, right? So we're gonna subtract 1 from both sides, and we're gonna be left with 2, right? So we're gonna be left with 2 equals 2, 4 minus h. All right. So then when we get down to here, we're now going to solve for h. What we have to remember is once your bases are the same, all you're asking yourself is, how can your exponents be equal to each other? So if this exponent equals 1 and this exponent equals 4 minus h, what would h have to be for this to be a true statement? Okay. So what would h have to be in order for this to be a true statement? Well, h would have to equal 3. So our h equals 3. And it has to equal 3 because 4 minus 3 is 1. So now we have our h equals 3. So our g of x for this problem, let me switch colors. We have g of x equals, we now have all variables. We have our b, h, and our k. Our b is 2, agree. X minus 3, because our h is 3, plus our k, my horizontal axis, was 1. That is how you figure out without a calculator, okay? So this would be without a calculator, all right? It says state the domain and range of g of x. So the domain here, our domain is from negative infinity to positive infinity. Our range is from our asymptote to infinity. So our asymptote is at 1, and it keeps growing, all right? Find the equation for the inverse of g of x. So the inverse equation means that we're going to find, in this case, the log, because the inverse of an exponential is a log function. There's a couple ways of going by and doing it, but I think the main thing is that your goal is to get your, switch your x and y, and then get your y by itself, right? So in this case, we're going to have x equals 2 to the y minus 3 plus 1. Okay, so I'm subtracting 1. I'm left with x minus 1 equals 2 to the y minus 3. All right, we're going to take the log base 2 of both sides. The reason why we're taking log base 2 of both sides is that we learned in Algebra 2 that that is how you cancel out a exponential. 2y. Okay, so log base and exponential base are the same. They cancel out, and you are setting your exponent free. We're left with log base 2 of x minus 1 equals y minus 3. Okay. So after I have y minus 3, I'm now going to add 3. both sides. So I'm left with my inverse. So my inverse equals log base 2 x minus 1 plus 3. And that's my inverse function. Okay, your inverse is going to be a log of the same base as your exponential. All right, and I know, again, I crammed a lot on this slide. So don't hesitate to ask questions. All right, now we're going to go on to stating the domain. Where am I at? Oh, I didn't cut it all off. Okay, it's okay, cool. We're going to create a little table here of our inverse. So I'm just going to use these values because they're whole values and not decimals. So remember, for inverse, that means that your x and your y are switching. So for my table, my first values would be, instead of 3, 2, my x would be 2, my y would be 3. Instead of 4, 3, we're now at 3, 4. 5, 5 makes no change. And then instead of 6, 9, we're at 9, 6. And then instead of 7, 17, we're now at 17, 7. Okay? And that's because, again, our inverse that we came up with, the inverse of our function is log base 2 x minus 1. Yeah, x minus 1 plus 3. Okay? So that's a table that goes with that guy. The domain here. So when I'm thinking about the domain, sometimes it may be easier to see the graph. So we're going to look at the graph to see what's happening with our domain and our range. However, keeping in mind what your domain and range was for your, no, I know I put it here, for your g of x. For our g of x, the domain was negative infinity to infinity. That's our domain. And our range was 1 to infinity was our range. Okay, so logically, if we switch our x and y's, what does that mean? We also switch our domain and range. So whether I graph it or not, if I know the domain and range of g of x, I know the domain and range of the inverse of that. So the domain here is going to be the range from here, which is 1 to infinity. The range is going to be the domain of the original, which is negative infinity to infinity. Okay, now we're going to go ahead and create a graph of both. I'm going to go ahead and graph the inverse since that's the color that I have in my hand. So for the inverse, I know that instead of a horizontal asymptote, it's a log. I'm going to have a vertical asymptote, and I have a vertical asymptote at 1. So I have a vertical asymptote at x equals 1, 2, 2. And pretend that's the straightest line you've ever seen. I ask you kindly to do so. And now I'm going to graph the rest of my points. So the rest of my points are 2, 3. I'm going to go to 2, go up to 3. I'm going to go to 3, 4, go to 3, go up to 4. I'm going to go to 5, 5, 5, up to 5. And then we have 9, 6, so 9 up to 6. And then we have 7 up to 17. But 17 up to, well, 17 is going to be off. But 17 up to 7 is not going to make it. But it's somewhere over here. Okay, I can't even pretend that that's a straight line at the bottom, y'all. Just trying to go with it. We'll just accept it. But that didn't work. Silly me. Let's try it again. Pew, 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 pew. Okay, so concentrate, pretend that I went through that point. And then concentrate. Okay, there is my inverse, my G inverse. All right, now I'm going to switch to red and do my original. So on the original, plotting these points, but on this one, it had a horizontal asymptote at Okay. And again, I'm going to use the whole values. So we're going to go to 3, 2, 3, 2. Hold on. I pressed the wrong button, guys. Close that on me. Make it big again. Okay. We're going to go to 3, 2. So we're at 3, 2. We don't want that. And then we're going to go to 4, 3. Now we're at 4, 3. Okay. 5, 5. 5. I'm going to go to 5, 5. Okay. And then we're going to go to 6, 9. 6, 9. And then we were at 7, 17. So 7, 17 is going to go off page. All right. And now we're going to do our best to connect. I'm thinking that it's just okay. Again, it's the pen and the board. I definitely didn't touch the asymptote, but I didn't go down enough. But you get the gist of it. All right. So there is our g of x. Okay. We can visually see that they are inverses of each other. And we also have confirmed that they're inverses of each other because we found it. But that is what you need to be able to do. And notice that we did all of 9 without a calculator. Okay. So this is an example of a potential calculator question that you would have to do. If you have any questions, comments, or concerns, please let me know. Thank you.